Welcome to part 5 of Competency 5. In this video, we will work with shifts of functions. You may recall that there are 4 basic shifts or transformations of functions. In our examples here, we have the parent function x squared. We show the shift up and then the shift down, as well as the shift to the right and the shift to the left. You might want to stop the video and take yourself a screenshot. Remember, these are very basic. You can combine these and then they become more complex as you change your parent function. Remember, this can be done with radical functions, rational functions, pretty much any function, and it looks different depending on the parent function. If you're not familiar with these properties, you might want to stop the video and go find some other resources before we move on. Number 1, write the equation of a function that lies 7 units to the right of the graph g of x equals x to the 6th. Okay, well, I can see that option A, that is 7 units up. Option B, that's simply 7 units down. Option C, now that's a little different. All right, what you're really doing is you're pulling out, here, let me show you. We are pulling out x plus 7 equals 0. So that implies that x equals minus 7, and that would be shifting to the left. So we can go ahead and get rid of these up and down ones. Now that one would be shifting to the left. So that would be a shift this way. Now, D would be what we want. That will be a shift to the right. That's what they asked for, because X would actually equal 7. However, we're going to graph that to check. Always graph to verify. So let's do X equals and then arrow over. Let's say X, caret up, and a 6. Now we go down, we're going to have to put this in parentheses. Remember, when we have our item in parentheses, that always gives us a right or left shift. It's up and down when the item is simply put here on the end of our original function. So we're like changing this part of our original function by creating that parentheses. Okay, well, that being said, let's say parentheses open, and then we have an x minus the 7, because it's the 7 that we're looking at, and then close, caret up 6. Now, let's graph them and see if it really does shift, okay? And there's our original. Ooh, they're both in pink. Well, let's go ahead and do this right here. Changing colors. What do we do? Notice how I've highlighted. Now, mine may look a little different here with what you see. It should be basic, or you may have what they call one of these applications turned on. Oops. So let's go back. Don't worry about it. Go ahead and just enter, okay? If you're new to the TID4 and yours looks different than mine, go ahead and just highlight it and go with it. Okay, so let's change that color and something that pops. Green's good with me. Good enough. Let's go down. Let's see here. Now let's graph so we see the difference. Okay, so we have shifted to the right, and it is 1, 2, 3, 4, 5, 6, 7. Okay, awesome. D has been confirmed. All right, number 2. Write the equation of a function that lies 8 units. 8 units below, that's down. Oops. Down. It'd be great if I could write. Okay, down this graph. We have a radical graph. That's a parent radical. All right, let's do it. Let's graph it first. Let's clear this out and say second. Remember, you need the x squared because the blue radical is right. Oops, it's right here. Oh, look at what I did. Let's clear it all out. Let's start over. Okay, second and x squared. Okay, push X. Right now, go down. And now we need to decide which one we want to work with. We're only shifting down. It's 8 units, but it's down. Okay, that means we need this one. Remember where I highlighted here on number 1. Plus the constant means we go up. So it would have to be A. But let's double check. So second second x squared, then put in my x, arrow over, and let's say the plus 8. Now let's push graph. Okay, now see, it is up. Okay, and we need to, that blue doesn't exactly pop. But see our green, at least we made that to where we could see it very clearly. And we are shifting up only. We're not going left to right, so we're good to go. That means A has been confirmed. Well, B doesn't work because it shifts down. And C and D, even though they don't have parentheses, they're going to shift left and right. We don't need the parentheses because we're encompassed completely under that radical. Right. And let's change that blue too. Doesn't pop enough, I think. So let's enter maybe a light blue on that black background might work better. Orange might be good. Let's try a light blue and see what happens. Let's look at them. Okay, go arrow all the way down to the, okay, push enter. Now let's see our graph. Okay, now we see something that shows up enough. Good enough. Okay, now let's go to number 3. Write the equation of a graph that lies 3 units to the left. We're going to go this way. And 2 units down. Okay, and we still have the same parent function or original function that we need. Okay, so let's go x equals. So we're keeping number 1 as is. What we're doing is we're changing the y2. Okay, so which one do we think we need? Well, we need 2 units down. So that would be a -2 constant on the end. Well, there's only one. That's going to be 3 down. This is 2 up, and that is 3 up. And it definitely says down. We don't want any of these, so let's try to see. Now, notice we haven't checked underneath the radical, but it says 3 units to the left. And this would be to the left. That would be x equals negative or -3. Okay, so what do? We go over here, go there, see, and it's letting us go underneath the radical, so we can say +3, but you need to go over and say -2. Remember, I had to arrow all the way out of it. If you don't arrow all the way out, you're still going to be under that radical, and it's until you get in the habit, it's kind of annoying. Okay, looks like we're good. Let's graph. Oh, yes. And if you remember, we started with the blue. The blue was our original right here. We did it in the blue. So it says go left 3. 1, 2, 3, down 1, 2. Verify. And to do that, you need to start at the origin and count when you're gauging these visually. Okay. Number 4. Write the equation for the function that lies 1 unit to the left. So we need to go 1 to the left and then 1 unit up. Well, before we enter in our calculator, and that is for the parent function 1 over x. Okay, before we enter, like I was saying, up would be a +1 constant, just kind of hanging on past what would be our parent function or the form of it. So this goes down, B goes down, C goes down, they're out. So now we're left with A and D, okay? And in the denominator, what do we need? It says we need x equal to, if you go to the left, that's -1. So that means x must equal 1. X plus 1 equals 0, actually, is what we're looking for. Okay. All right, let's do this a little better. All right, so let's see. That means we need D and verify in the calculator. We're always going to verify. So let's say alpha y equals, number 1 is what we want, and 1, and then over x. Okay, now we have that in our parent, our given. Now let's go down. And again, we're going to have to say alpha y equals, and then 1's what we want. And then this time we need 1 over x, but plus 1 is what we want, but arrow all the way over to get out of that fraction. And then let's say plus 1. So we shift the right direction. Now, push graph to see if we're correct. Okay, yes, we are. Now, be very careful what you're doing here. When you look at this, start at the origin and the light blue. And where are we shifting? We are shifting, it said to the left. Okay, I'm going to go to the left 1 and up 1. So that's where I should be, right there, in between the green. And if you look as I do this, we are right in the center, kind of like in the center of the green. So it is a shift to the left 1, up 1, obviously. So verified visually, and D is correct. Number 5, write the equation of the function that lies 2 units up. So we're going to up and 2 units to the right. Okay. Now, let's look at our options. You may have already noticed every single option is 2 units up. So that isn't going to help us out. However, let's look at the next operation after 2. That's actually shows us if the quadratic opens up or down. Because notice they said, hey, you need to look at the graph, the parent function of x squared. Well, this is just if it opens up or down. Well, our question doesn't care if it opens up or down. We just care about the shift. So that's not going to help us. What we need to look is at our right or left shift. Well, it says that we need to go to the right. So that means x would actually have to equal 2 to go to the right. So that means x minus 2 would equal 0. So kind of working backwards. Let's see which one of those. Oh, you know what? I see something we need to talk about before we even select that. A and B have this situation. A and B are out because that's not really going to be from our parent function. Those would actually be a form of what we had above in number 4, a rational function. Okay, those will be in the denominator. That would be 1 over x plus 2 and 1 over x minus 1. So A and B are already out. So they're done. So then that just leaves us, since we're ignoring our plus and minus highlighted, the only option it possibly could be is C. So let's graph that. Okay, let's see, we need to clear this out, and that is x squared. Go down, over, clear again, and now we have 2, but it says plus, open parentheses, x minus 2, close out parentheses, and oops, wrong one. We can just get rid of that by typing over it. There we go. Not a problem. All right, now let's graph it. Okay, and yes, we go to the right, which is what it asks for right here. So we go to the right 2 and up 2. So again, verify. All right, moving on to number 6. Now this is going to be different. And our calculator won't help us a lot, okay? It says if f of x equals x squared, write the equation of the function in the form, now that's important, this form is highly important, g of x equals f of kx. Okay, whose y values are 1/25th as large as the y values of f of x for a given set of x values. That's like blah, blah, blah confusing. Let's just stick to the facts and we'll get there. Okay. First off, they asked for this form. Don't deviate from that form. Okay. Well, B deviates and D deviates. Now, in the end, they want you to have, which is implied here, we need to have an ending value, like a change, a transformation of 1/25. Okay. So let's look at this. Let's look at the K. In our form, we need K equals, but we are given this. That's actually K squared equals 1/25. Okay. Whose y values are 1/25th as large as the y values of f of x. So f of x is our parent value, and we want to take it and make it 1/25th as large. Okay, so we want to change it and ignore the words as large because that makes you think you're getting something bigger. Don't worry about it. We just need to alter it. But what you see here is we can get K. Obviously, if we put both of these under the square root, we are going to get this. And that tells us automatically that the form that we're looking for is A. Okay. Now, C is not a good form because it kind of mixes things. And let me show you what I mean. If we actually take our form and use it with the parent function, this is what we will get. We will get, let's call it g of x. Actually, probably shouldn't even call it g of x, to be honest with you. Probably ought to call it like h. And this is totally different. The form we're going to end up with in the end is going to be 1/25x squared. So now let's analyze what we see here with the words that we were given. 1/25th as large as f of x. So you go back to f of x. So that's 1/25th times, that's what as large as means, times our parent or original function, x squared. So now that I've written it out, now that makes sense. So if we had started with this and multiplied this out to look like this, probably would have made more sense. In my mind, that's what I saw, but not everybody would see that right away. Okay, this is the last question in this particular video. Guys, thank you so much for watching and sharing us and liking us. Please keep sharing our videos. Somebody out there might benefit from them, and that would be great. And we really, really appreciate all the subscriptions. You guys have been the best. Happy testing, everybody.